Now that we've looked at ways to know if triangles are congruent without knowing every single side and every single angle is congruent, we are going to do triangle proofs. Not my favorite thing, but we got to do what we got to do. So for triangle proofs, our goal is going to be to use one of these 5 triangle congruence postulates to state that 2 triangles are congruent. Remember, we have these 5 that we could use. You cannot use angle, 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 or side, side angle unless it's a right triangle. You can use side, side angle. That's called hypotenuse leg. So what we have to do before we use these theorems, though, is find some congruent sides and congruent angles and prove that they are congruent. All right, so let's do some examples together. It is going to be helpful if you have this web paint or something where you can write on your screen. I would highly recommend using that. All right, so this says given. It tells us some statements that are given, and then it tells us what we are trying to prove. To prove that 2 triangles are congruent, the reason is always going to be one of these 5 statements here. So at the end, it's going to be one of those 5. So the 2 triangles I like to look at overall what we're trying to do, and we're trying to prove that this triangle and this triangle are congruent to each other. They've given us 2 sets of sides already, so we can use one of the theorems that has 2 sides. So it's either going to be side, 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 or side, angle, side, probably. To find more congruent sides and angles, this is kind of a checklist that it might help you to go through. The first thing we ask ourselves is, are there any sides or angles that both of these triangles share? Yes, they share AC. That is equal to itself. That's where it overlaps. So what I'm going to do is say that AC is congruent to itself in each of these triangles. So AC is a segment, so I'm going to click on the first one, which is a segment, and say AC is equal to itself. You're going to see things being equal to itself a lot, and you need to remember that the reflexive property is going to be the reason anytime something equals itself. Next, we want to see if I have enough information to use one of these 5 postulates yet. I have 3 sides in both triangles. So are these 2 triangles? Do we have enough information now? Yes, we can use side, side, side to prove that these 2 triangles, when you're doing the last step, you can actually just copy what it says up here. And then the reason that these 2 triangles are congruent, again, anytime you have 2 triangles here, your reason is always going to be one of these 5 reasons. In this case, it is side, side, side. Okay, the cool thing about Delta Math is if you move your mouse over these, it will highlight certain things for you, so that helps you to visualize that. We didn't have that when I was in school working in a textbook. Okay, another example, we've got given and prove. We're trying to prove that 2 triangles are congruent, so the last statement I'm going to make is going to be this right here, and the reason is going to be one of these 5 reasons. I notice they've given me a set of sides and a set of angles. So we need to use one of these that has a side and an angle. We don't know which one yet. We're going to have to find if there are more sides or angles that we could figure out are congruent. So first step, they gave us that AD and DC are congruent segments. Angle A and angle C are congruent. Then we can go through our checklist to see if we can find some more sides or angles. Are there any sides or angles that these 2 triangles both share? No, they're not. Any parallel lines? No, parallel lines would have arrow marks. Are there two congruent sides or two congruent angles? We don't have anything isosceles. Are there any vertical angles? Aha! There are vertical angles in this diagram. What are the two angles that are vertical angles here? We've got this angle and this angle. Those are vertical angles. Anytime there are vertical angles, they are congruent. So we are going to state that those two angles are congruent because the reason is going to be because they are vertical angles. So I'm going to click on my type of statement is going to be angles. And those are vertical angles. You can type in reason, so you could start typing vertical if you needed to. And then, do we have enough information now to say that these two triangles are congruent, and which one would we use? Yes, we do have enough information because we have angle, side, angle. So I'm going to type that these two triangles are congruent. Remember, I could just basically copy what it says up here, and the order does matter. The order does matter when you're naming the triangles. And the reason we would use for this is angle, side, angle, because the side that is congruent is formed by the two congruent sides. Another one, we are given AC, and then we have this symbol right here, this upside down T. Okay, that means perpendicular. So we're probably going to be using this last statement right here. Also, it gives us that angle A is congruent to angle C. And let's see what else we can figure out. Again, we're trying to prove that these two triangles are congruent. So the last step is going to be this statement with one of these 5 reasons. So again, I know that there are perpendicular sides. When there are perpendicular sides, we know that perpendicular sides form right angles. So I can say that a couple of these angles are right angles based on the fact that AC and BD are perpendicular. They make a right angle. What would the two right angles be? ADB is a right angle. The reason we know that is because perpendicular lines form right angles, and the other one is going to be BDC. BDC is a right angle also because perpendicular lines form right angles. On Delta Math, though, you still have to say all right angles are congruent. So just because you have said that this is a right angle and this is a right angle, you still have to say that they're equal to each other. So yes, we know that these are both right angles, so obviously they're equal, but we do need to tell Delta Math that. So we are going to state two angles are congruent, ADB and BDC. These two angles are equal to each other because all right angles are congruent. So anytime there's perpendicular sides, you can say that you have right angles and that all right angles are congruent. All right, let's see what else we have here. We've got two angles now, and two angles, angle, it's not enough information. We need another side. We can't do another angle because there's no angle. So let's see if we can find any other sides or angles, starting at the top of the list. Are there any sides or angles in both of these triangles that overlap? Yes, they both share the side BD. So I'm going to say that BD equals itself, and what do we put anytime something equals itself? That is reflexive. So now I have a side and I have two angles. And based on the order, let's see if this falls into the category of any of those 5 theorems. Yes, this would be angle, side. So again, I would just copy this down and say angle, angle, side. Let's look at some more. We are given that CA bisects angle BAD. Remember what bisect means? Bisect means it splits into two congruent angles, and it gives us another angle. Angle B is congruent to angle D. Right now, we just have one set of angles labeled congruent, so we need to see if we can find any other congruent sides or angles looking at this checklist. Are there any sides or angles that these two triangles share? Yes, we would have AC is congruent to itself. Anytime something is congruent to itself, what do we put? That's the reflexive property. So both of these triangles share AC. We've got an angle and a side. We need to either find another side or another angle to see if we can use one of these. Let's look at the fact that it says bisect. A bisector of an angle splits into two congruent angles. So this tells me that CA bisects angle BAD. In other words, it splits angle BAD into two congruent angles. So those two angles have to be equal to each other because it bisects. Let's write what those two angles are. BAC and DAC are the congruent angles. And again, the reason we knew that was because it said that it bisects. So in the reasons, I'm going to look for something that says bisect. You can even start typing bisect. An angle bisector divides into two congruent angles. Now, do we have enough information to say these two triangles are congruent? Yes, we do, and the reason would be angle, angle, side. The side that's congruent is not between the two angles. Next, this time we're given that AB. Do you remember what this symbol means? That means parallel, so we're going to be using parallel lines here. We've got parallel lines here and parallel lines here, and we're going to see if that's enough information to prove that these two triangles are congruent. First of all, let's go in our checklist. Are there any sides or angles that overlap? Yes, so one of the reasons it's going to, or one of the statements is going to be that AC equals itself reflexive. That's a side in both of these triangles, so we're going to put that. Next, remember these marks don't tell us that anything are congruent. Those are the marks for parallel. When there are parallel sides, we're going to look for that Z shape to see if there are any corresponding alternate interior or alternate exterior angles. That's a throwback from this back here. So you should notice that since we have these two parallel lines here, and this line is like a transversal. We've got parallel sides and a transversal. We've got this nice Z shape here. And anytime there is that Z shape, it forms all of these relationships here. And which of these angle pairs would help us with these two triangles specifically? The two angles that are in these two triangles in that purplish Z that I drew would be this angle right here and this angle right here. Those are going to be alternate interior angles. Alternate means they're on either side of the transversal. Interior means inside the parallel lines. So I'm going to state that those two angles are congruent. Angles BCA and DAC are congruent because if there are parallel lines, they're going to be alternate interior. So you could just type alternate interior. And that's how I know that those two angles are congruent. So now I have a side and an angle. Parallel doesn't tell me that anything is congruent. So I still need something else based on the fact that I'm using one of these 5. So let's see if we can find any other sides or angles. Again, we have not used the fact that these 2 lines, A, B, and C, D, are parallel. So let's see if we use the fact that those 2 lines are parallel, the fact that these 2 lines are parallel, and those lines are also cut by a transversal. So we have this Z shape again. It's a little bit turned sideways, but we have parallel lines and a transversal. So we have this Z shape here. And in these 2 triangles, do we also have alternate interior angles for this one? Yes, we do. The 2 angles that are alternate interior angles would be this angle right here and this angle right here. Those are alternate interior angles for parallel lines. So we'll put that statement as well. Angle BAC would be this angle right here, and angle DCA would be this angle right here. Those are also alternate interior angles. Now, let's see if we have enough information to state for sure that these 2 triangles are congruent using one of those 5. Which one could we use for this? We could copy this down and state that it would be angle, side, angle. A lot of those. Let's do a couple more because these are all different and I want to do a lot of examples with you. We are given that D is the midpoint of AC. We are given 2 angles that are congruent. Let's see if we can use that to figure out that AED and CFD are congruent. So really, this extra thing here doesn't really have to do with anything because we're just trying to find that these 2 triangles are congruent. With those 2 triangles, I have this checklist for you. Let's go through the checklist and see what we have with these 2 triangles. We have, it says midpoint. So we're going to use the fact that D is the midpoint. And when it says midpoint, I see midpoint right here. The midpoint always splits a segment into 2 congruent segments. So which 2 segments would be congruent? AD and DC. If D is the midpoint of this line, then it splits these 2 into 2 congruent segments. So this is going to be that we have 2 congruent sides now, AD and DC. And the reason is because it said the word midpoint. So I'm going to type in midpoint or look for midpoint. And now I've got 2 congruent sides. So I've got angle, angle, and side. Let's look at the order to see if it's angle, side, angle, or angle, angle, side. And these sides that are congruent are not in between the 2 angles. So this one would be angle, angle, side. I'm going to do one more example with you. There are all different types of questions, so you might see some that are nothing like the ones that I've done. I'm sorry, that's just how it is. All right, so we're given first that we have some perpendicular sides. Remember, perpendicular sides are going to give me some right angles. And we've got some congruent sides. The 2 triangles that we are trying to prove congruent are ADB and BCA. So not just these 2 up here, but we've got 2 overlapping triangles here. And remember, I told you sometimes you might find it helpful to draw out the triangles separately. Once you draw those out, you need to make sure you mark everything as well as label them. And let's see what else we could come up with. We've got our right angles here. Anytime there's perpendicular sides, we're going to get right angles. So angle ADB would be this angle right here. BCA is also a right angle. So we know that those will be congruent because all right angles are congruent. So what we would want to do is state that we've got some right angles here and all right angles are congruent. I've got angle ADB because perpendicular lines form right angles. Also, BCA is a right angle. Now I need to see if I can find any other sides or angles in these two triangles. So what I'm going to do, starting at the top of my list, are there any overlapping sides or angles? Yes, they both, when they overlap, AB, they both have AB. So AB is congruent to AB. So those two segments would be AB is congruent to itself. Anytime something is congruent to itself, we say reflexive. We've got an angle and we've got two sides. So let's see if that's enough information. An angle and two sides, and the two sides are not on either side of the angle. So this would be side-side angle or angle-side-side. Does side-side angle work? Only if it is a right triangle. And is this a right triangle? Yes. So that means that we can use hypotenuse leg because this is the hypotenuse across from the right angle and the leg. Okay, but on Delta Math, you have to state that it's a right triangle before you use hypotenuse leg. So we would classify a triangle and we would say triangle DAB is a right triangle because it has a right angle. And then you say the same thing for this other triangle, CBA, because it also has a right angle. So you have to state that they're right triangles before you state that they're congruent by hypotenuse leg.